This is Boraton Z. This time, I want to show you how to convert the hair of a girl character created using a geometry node-based hair system into low-poly mesh so it can be used in games or for VTubers. You often see methods where low-poly hair is created by attaching a mesh along a curve. That is definitely one way to do it. However, since we already have geometry node-based hair, I want to explore a method for creating hair that utilizes this convenient and intuitive approach. This technique can be applied to many things besides hair. So, if you want to create 3D CG easily, intuitively, and enjoyably, please watch until the end. This channel aims to share tips and information for making 3D CG fun, targeting those who are thinking about starting 3D CG or want to make 3D CG their job. If you like it, please subscribe to the channel and give it a thumbs up. Now, let's get started. First, we want to convert the geometry node-based hair into a low-poly mesh. We move to the Geometry Nodes workspace. Geometry Nodes is a function in Blender that uses nodes to create shapes. By connecting nodes, you can arrange cubes or place them along a curve. You can easily adjust the shape and placement by changing the numerical values. Its characteristic feature is the ability to automatically generate shapes by setting rules rather than doing it manually. It requires a programming-like way of thinking, allowing for the efficient creation of complex shapes. When you select the hair curve, you can see that many geometry nodes have been assembled. However, editing this can be difficult, so we want to make it simpler. We will delete the modifier set on the geometry nodes of the hair curve. We return it to the state where only an empty hair object is set. From here, we will assemble geometry nodes to convert the curve into a mesh and create the hair. We will add nodes between the group input and group output in the node editor. First, since we already have hair as curves, we will convert these curves into a mesh to create a polygon tube. Add the Curve to Mesh node from the Add menu under Curve Operations. We connect it between Deform Curve on Surface and Group Output. When you drag it between the connecting lines, the line turns white and dropping it connects them. Add the Arc primitive from the Curve menu and connect it to the Profile Curve input. This turns the curve into a mesh tube. You can adjust the size with radius and the opening and angle of the mesh with sweep angle. You can set the number of sides using the resolution value, so we will keep it low for a low polygon result. Alternatively, you can add a new curve and use that as a reference to create the mesh. In Object mode, add a NURBS curve from the Add menu and edit its shape to make it easier to understand. Select the hair curve and pin it. Select the NURBS curve and drag and drop it into the node editor. An Object Info node will be added, and connecting its geometry output to the profile curve creates a tube in that shape. By editing this base curve, you can create stylized hair, so give it a try. Now, let's revert to the arc and set the resolution to about 6. Also, since the arc is not closed at the ends, we connect Merge by Distance after Curve to Mesh. Next, to make the tips thinner, we add the Set Curve Radius node from the Curve menu under Right. We connect it before Curve to Mesh. Then, we add the Spline Parameter node from the Curve menu under Read and connect the factor output to the radius input. Since the root side is now thin, we add the Float Curve node from the Utility Math menu in between. By editing the graph of that curve, you can change the thickness. We can also add a Transform Geometry node after the arc and scale it to make it elliptical. If we look at the wireframe display, there are many segments, so we add the Resample Curve node from Curve Operations before it. Changing count to length allows you to make the interval constant based on length. This completes the conversion to a low poly mesh. To set the material, connect a Set Material node after Curve to Mesh. We have successfully set the material. At this stage, the overall shape of the hair is visible. Of course, you can still use the geometry node-based hair system. You can edit the hair using tools like the comb and add tools. Next, we want to set a hair-like texture and enable UV mapping so it can be used in other applications. Add a Capture Attribute node from the Attribute menu and connect it between Set Curve Radius and Curve to Mesh. Then, add a Spline Parameter node and connect the factor to the bottom socket. Add another Capture Attribute node and connect it between the Arc and Curve to Mesh. Connect the length output from the Spline Parameters Capture Attribute. Next, add a Store Named Attribute node from the Attribute menu and connect it before Set Material. Change it to 2D Vector, Face Corner, and name it New UV. Add a Combine XYZ node from the Utility Vector menu and connect the vector output to the value input. Connect the Factor attribute from the Curve Radius to Y. Connect the length output from the Curve Circles Capture attribute to X. Now that we can obtain the coordinates in the shader editor, we will set the texture. Move to the Shading workspace and display the Shader node editor. Add an Attribute node from the Add menu and type in New UV. And connect the vector output to the mapping. Add a Noise texture and set up a normal map. Adjust the scale of the mapping. By connecting a color ramp in between, you can strengthen the contrast and adjust the normal. Mix the Ambient Occlusion node into the color. This allows us to give it a hair-like texture. Next, we want to use an image texture for a more realistic hair texture. First, we create a realistic hair texture. Start another instance of Blender and create a new scene. Delete the cube and add a grid. Select the grid and add an empty hair curve. Switch to Sculpt mode, grow one strand of hair, rotate it 180 degrees, and make it face downward. Set the viewport to the front view and create a camera. In the camera properties, set the lens type to orthographic. In the output properties, set the format to 2048 by 2048. Delete the original camera. Adjust the hair length so it fits within the camera view. Open the Hair Asset browser and start setting up hair modifiers. Drag and drop Set Hair Curve Profile to set the thickness of the hair. Next, set up Duplicate Hair. Set it to about 300 strands. Set up Frizz Hair Curves to add a scattered look. We will keep the settings like this for now. Duplicate the curve using the Object menu and slide it horizontally. Repeat the duplication until about half of the area is filled. For the latter half, we will fill it in a little more scattered manner to add variation. At the very end, we will create just one single strand of hair. In the render properties, set the render engine to Workbench. Set sampling to 16 samples. Set lighting to Studio. Set color to single and the color to white. Check transparent under Film. Now execute render image. In Image Save, set the format to PNG. Set color to RGB. Save it with the name Hair Diffuse. Next, we create the normal map. Select Normal in the Lighting Matte tab. Uncheck Transparent under Film. Execute Render Image. Save the normal as RGB with the name Normal. Finally, we also create the Ambient Occlusion map. Return lighting to Studio. Check the Cavity option. Adjust the world space value. Execute Render Image. Save it as AO. This completes the hair textures. Now, return to the character and set the textures on the hair polygon shader. Keep the previous shader's attribute and mapping nodes and delete the others. Change the shader from Principled Hair BSDF to Principled BSDF. Add an image texture node from the Add menu and open the diffuse texture we created. Connect its color output to the base color input of the Principled BSDF. Connect alpha to the alpha input of the Principled BSDF. Since the UV values are inverted, set the Y scale of the mapping to -1. By setting the X scale of the mapping to 0.5, we can use the texture range that we packed into half the space. Next, add a normal map texture. Connect it to a normal map node, and then connect that to the normal input. Add the ambient occlusion texture as well, and multiply that over the base color. It is recommended to enable color modification so you can adjust the hair color in the shader. By adjusting the color of the subsurface and specular settings, you should be able to achieve the desired look. Even at this stage, it is possible to adjust the hair using hair sculpt tools, so you can confirm the look while making adjustments. Next, we want to add a single stray strand of hair. Select the hair curve and duplicate it. Hide the main hair. In sculpt mode, delete the hair curves. Once all are gone, add one strand of hair near the bangs. Copy it in the Geometry Nodes workspace. After adding it, reduce the radius value of the arc. A thin strand of hair has been added. Return to sculpt mode and edit it with the comb tool. You can also copy the shader and make it unique to create different variations. Go back to Geometry Nodes and change the set material to the newly added material. This way, you can easily and enjoyably create as many additional strands of hair as you want. Finally, to allow the finished hair to be exported, we convert it to a mesh. Select the curve and choose Convert to Mesh from the Object menu. Once converted to mesh, check the UV map in Data Properties. If it says New UV, it's okay. If it is not set, you need to use Convert Attribute on the New UV attribute to change it to a 2D vector face corner. How was that? Using this method, you can easily, quickly, and enjoyably create high-quality hair, right? It's quite versatile, so please try various things. Now, off to the world of infinite imagination.
Hey, you rusty robot over there.
Ah,
I don't have a body.
we will create the body in the next video.
So that means I still don't have a body? Oh dear, what should I do?
Well, please bear with my old body for now.
Ah, I can move now. Thank you very much. Please create a wonderful body for me in the next video then.
Understood. Now, let's pull ourselves together.
Let's leap into the world of infinite imagination.